As we dig further into enhancements to our cube, we're going to start looking at key performance indicators, or KPIs. Key performance indicators, or KPIs, are a way for business to look at performance metrics. The object first consists of a value and a goal. We've seen these values with our measures. Based on those numbers, the status and trend can be computed. The status will be from the comparison of the value and goal, and the trend will be over time. Client reporting tools will have to be able to read this metadata for this type of object from the Analysis Services multidimensional cube. Excel pivot tables provides use of displaying all these properties, including the value, goal, and the indicator, status, and trend. Additionally, SQL Server Reporting Services and integration of Performance Point and SharePoint provides the same functionality. To define a KPI, or Key Performance Indicator, we're going to have to use the MDX language, Multidimensional Expression Language. The KPI object is programmed in this language of the Analysis Services multidimensional cube. This language will be expanded upon in other sections of this training. The definition of the KPI object includes the actual value, and in our example, we will be using the gross profit margin, which is a ratio or percentage. The goal will be based in reality on a product category, but initially we're going to create a single goal of 40%. Here we have to use some MDX in order to compare the different category KPMs to the goals and statuses of that property. The variance from the goal will be computed to assign 3 types of statuses: 1 good or green, 0 okay or yellow, -1 bad or red. In order to get the trends over time, we're going to need to use the calendar date and the year hierarchy attribute. Over time, the trend will need MDX to compare these differences. We could include quarters and months as well. This property will be an indicator symbol that will show arrows to up, down, or level. Lastly, templates are available to help, and we will use this in the gross profit margin KPI. Let's go do a demonstration of KPIs. If we do not have the Data Tools interface open, let's go ahead and open it. From Start, we'll click SQL Server Data Tools. It'll open up a blank solution. Here we can go to the File menu, Recent Projects or Solutions, and open our previous solution. Key performance indicators are inside the cube itself, so we're going to open the Solution Explorer and double-click our VentureWorks cube. Here we've gone over the cube structure, the dimension usage, and calculations. The next tab is KPIs. We can right-click in that KPI organizer and create a new KPI if we know the syntax for all the expressions. But instead, we're going to delete this created KPI and go down to the bottom calculation tools and go to templates. This is real convenient to have KPIs as templates and kind of fill in the blank. We'll click the All, scroll down to Gross Profit Margin, double click, and it'll create a gross profit margin KPI for us. We're going to keep the name the same, Gross Profit Margin. We can't associate it with a measure group because it's really the Sales Summary Display folder. When we go to Expression, it actually shows us dividing the gross profit by net sales times 1,000. We're going to delete this from the expression and go to our metadata. When we drill into Measures and Sales Summary, we can drag our gross profit margin into the expression. Now we have a value. Next is to place a goal, and it gives you a description that says this can be a fixed value if you know your gross profit margin goal. For now, we're just going to put 0.41 because we're not sure what our goals are. We're going to use the display of the KPI to determine how to categorize them by the product category. Next, we're going to scroll down a little and roll down the gauge status indicator. We're going to pick a cylinder instead of the gauge. You can see there's many options to choose from. Next, in order for that status indicator to have a value, we have to have an expression to compute this value. The template tells us an if function, in parentheses, the KPI value of this KPI, which would be the gross profit margin, minus the goal of the KPI. If that difference is greater than or equal to 0, it'll give us a status of 1, else -1. We're going to build a little further on this in a different part of this demonstration. Next, we'll look at the trend. It has a dark arrow. We're going to drop that down and pick a green arrow. The up arrow will be green, the even arrow will be yellow, and the down arrow will be red. In the description for the trend, it's going to tell us that this period and trend comparison is defined at a certain level by parallel period. So what it's doing here is another if statement. It's going to see if the value is greater than the value of a parallel period. So what we have to do is define what this parallel period is. Here it gives you an example that you might grab the time dimension, the time hierarchy, and the time year level. Well, we have that. We'll drill down in our metadata, go to order date, to our calendar date, and there is year. We're going to drag that out to the parentheses, highlight it, and cut it, and replace this value with it. So now we have our year to compare for a parallel period. The 1 after the comma means the previous period. Lastly, it needs a current member for the MDX calculation. And here you'll be tempted to put the year in there. Well, what it's looking for is the lower level of year of just the calendar date hierarchy. The current member will return that current year as displayed in our reporting tool. We're going to save this work and deploy our cube. Again, you should be constantly deploying changes just to make sure you can backtrack where the error might be. Once it deploys successful, there's actually a viewer for this KPI. We'll go to the viewer, and it looks like over time for gross profit margin, our value is 11.43, our goal was 0.41, the status is low, and the trend is up. Now, we don't have anything to slice this by yet, so it's looking overall at the cube. It even gives you a kind of warning message about what's going on with this calculation. So in order to view it better, we're going to roll down our dimensions and pick order date. We're going to go pick the hierarchy calendar date. Our operator is equal, and our expression is going to be an individual year. We'll pick 2012. As we move off that row, we'll see a calculation happen, and our value actually went down, and our trend is down. So probably if we go look at 2011, the value is going to be greater than 9.82%. And it is 11.37. Next, we're going to look at what we can do to display by product category. We'll go to Product, Hierarchy, Product Category, equals one particular category. We'll select bikes. Now that 11.37 should change, and it does to 11.45. So it looks like bikes, if we change the year, might be around 11 or 12%. Actually, it went down here to 9.15. So what we want to do is change our goal for bikes to something like 10%. Let's look at what components looks like. It's 11.42. And clothing, 21. When we look at accessories, we might get something even different. It looks like about 30. So let's go back to our KPI, and what I'm going to do is copy some MDX previously created for our goal expression. I'm going to go to a notepad, and I'm going to copy this case statement. Once I copy it and paste it into our goal, we will talk a little more about this. So let's look at this expression. There's a case. When the product category current member is accessories, it's fixing the goal at 0.75. I believe we had something more in the range of 25. For bikes, I think we had something in the range of 10, and for clothing, maybe 12. For components, I believe it was around 25, and we'll take all other cases as 10. Let's save these changes, deploy our cube, and once that deploys without any errors, we'll go back to that browser view. Now, if we change the year to 2013 and look at accessories, we'll see the value and goal change. It's 53 where the goal is 25. Let's look at bikes. In order for it to recalculate, you have to click off of the dimension you just changed. Here we have 12.29 and a goal of 1 for a status of green. You get the idea here is once you create it from a template, you can build further and further on what you do here. Let's go back to our KPI and look at the last area, which is our status expression. Our status expression is comparing that goal to the value, and it's only seeing a 1 or a negative 1 if the difference is greater than 0. Let's go back to our notepad and copy another case statement. So instead of just looking at something greater than 0, what we're going to do is compare it to actual percentages. We're going to see first if the gross profit margin value divided by the goal is greater than or equal to 90%. That's good. If it's between 90 and 80, that'll be okay. And if it's below 80, it's negative 1. We'll save this and deploy our cube again. All this is MDX that you're going to learn over time as you build more and more from templates and KPIs and calculated columns. We'll go back to our viewer, reconnect, and now let's look at our components. Our status is now red because it's 6.9 and had a goal of 25%. If we change the years and look at it, we see that we have a trend up, but it's still below our goal. Let's look at clothing. 2012, it was 21, which is a good status above 12, but as it moved to 2013, it went down in a trend and looks like it's about 15. Let's go back to our KPI and we're going to adjust some of these measures. So for clothing, we're going to change that to 11 and save. Now we're going to go and do something about the trend. So the trend here is just comparing a parallel period, and if one's greater than the other, put 1, else negative 1. Here's a little more complex MDX for this, and we'll go over what this means. I'm actually going to comment out this part by prefacing it with a slash, star, and ending with a star, slash. I'm going to go to the top and paste this code. Here we're looking to see if there's an empty value in the parallel period. If it's empty, we're going to put 0. Then we're going to look at an absolute difference of the comparing of the values on the parallel periods divided by the gross profit margin of another parallel period. If that's less than or equal to 0.02, we're going to put 0. The other expressions will give us the good and the bad, which is then 1 or negative 1. Let's save this and deploy our cube. Now, previewing it in the browser view for the KPI can give you some instance results, but it sure would be nice to look at this on a bigger scale. So let's go to the browser section of the cube. Let's analyze in Excel and connect to this KPI. Here we can place the gross profit margins, value, goal, status, and trend in Excel. Now this is for the whole entire cube. What we need to look at is the product category. We'll bring that to our rows. and then you'll see a little more information. Also, we need to pull in for our trend, since it's all showing good, the order date. If I go pull that calendar year into my columns and then just pick 2011, 12, and 13, I get a little more feel of what's going on. I can also move the values to the rows and get a better display of this. So here we can look at bikes overall in 2011, 12, and 13, their gross profit margin compared to a goal, and then the status. Below that we can see the trend. Same thing with components, and same thing with clothing. After we view this, we might adjust those goals to be more in line with what our actual gross profit margin is. As we continue our enhancements in this intermediate section, we're going to talk about name sets. So what is a name set? A name set consists of an MDX statement to grab a subset of data or dimension members. This gives the users that are browsing a cube a little more consolidation of the details and the more important details of doing analytical analysis. So what is a name set? It is a subset of the cube, like top 10 customers by sales or bottom 5 subcategories by sales gross profit margin. It is a quick way to have a set viewable by the end user. This will assist in pointing out the areas to look or drill into for more analysis of the company. A name set can get to be complex MDX or not complex MDX. It's in a reusable format that is persistent in the cube. It can also be created in the scope of a query by a client reporting tool. Why do we use name sets? Well, the end user wants to be able to pull up the top 10 customers by sales when browsing the cube. After more data is processed, the top 10 might change. The name set will reflect this top 10 change. The name set will reflect this, but the end user will not have to rewrite the query every time. MDX query behind the name set limits the data return, but does not limit the dimension hierarchies or attributes returned. But if you do specify that members are excluded, they can be excluded. Let's go do a demo of name sets. Alright, let's do a demonstration of name sets. With the solution and project open, we'll go to the Solution Explorer and double-click the cube. Here, we're going to go to the Calculations tab of the cube. We'll go to Gross Profit Margin and right-click and create a new name set. Our new name set is going to be Top 10 Customers by Internet Sales. And now we have some MDX to write. There's a function called top count, and inside of this function we need to put the dimension measure we're tracking. We'll go to customer, customer, and the customer hierarchy attribute as what we're looking at. We'll hit the enter key, go across, put a comma and 10. That means we want the top 10 count, and then after the comma we need to put the measure that we're comparing. We'll go to Measures, Internet Sales, and Internet Sales Amount. Here, we'll hit the Enter key and close the parentheses. We also need to put the Members function at the end of the customer attribute. Now we'll save this name set, go to the Solution Explorer, right-click, and deploy. Once it's finished deploying and we receive no errors for the deployment progress, we'll go see if our name set is created. We'll go to the browser and we'll reconnect to our cube. Now, even though you created it as a calculation, it's not under measures. You have to go to the dimension that you created it under, and if you notice under customers, we have a top 10 customer by internet sales. Here, if we drag this out, we first need to have our internet sales displayed in order to look to see the top 10 customers. And now we need to place it in a filter and then place the customer attribute onto our viewing area. Now we have a named set that will show us those top 10 customers. Even if we don't want internet sales, we can drag something like sales amount from the total as well as gross profit margin to see a comparison. We also can analyze in Excel. We'll enable, and then we'll pick the internet sales amount and go to the customer dimension. Once in the customer dimension, we could drill into the sets and drag the top 10 customers into our rows, and now we see our top 10 customers. We're going to return back to the cube and go back to calculation and create one more named set. We'll right click on top 10, we'll create a new named set, and this time we're going to look at bottom 25 product subcategories. And here, instead of doing a top count, we're going to do a bottom count. We'll go to the product dimension. Notice it says error retrieving nodes. If we go back and reconnect, it'll refresh that list for us. We'll drag product categories. Actually, we have to drill in and get the lower member. This is the product dimension, product subcategory hierarchy, which is an attribute hierarchy, and then the product subcategory member, or attribute. Here we'll add the members function, comma 25, comma internet sales amount. We'll just drag that from our metadata, and then we'll close that parentheses. We'll save this, go to the Solution Explorer, and deploy. Once it's finished, we can go back to Excel if there's no errors in our deployment, and go to the Data ribbon and refresh all. Now we'll drag the top 10 customers out and go down to the product dimension and drag bottom 25 product categories. And you'll notice here we only have 4 actual subcategories with a value. There's a function called non-empty in a select statement for an MDX query, and that's what Excel does. But if we right-click on the pivot table and go to Pivot Table Options to the Display tab and show items with no data, we'll see those other subcategories. The other subcategories have no sales at all, but they are included in the bottom 25.